So in this exercise, we are going to be focusing on the factorization of given algebraic expressions. If you are to consider the exercise that we are having in this case, you'll see that these are simply the binomials that we have, like we just have two terms in each and every question that we are given there. So whatever that you are going to do is the same, all right? Throughout, we are going to consider the same thing. And what is it that we are going to consider in order for us to factorize given expressions of that nature? So if you are given two terms, let's say I'm given a squared plus 2a like this. Whenever you are required to factorize this, and you must factorize this completely. To factorize completely, that means after factoring whatever that you consider as your highest common factor, you are not supposed to have anything common in the brackets. So to factorize is simply to put in brackets. This time we must have the brackets. So they are going to give us questions where already the brackets are there. They are going to ask us to expand the brackets, to remove the brackets and simplify. But in this case, we need to have the brackets at the end of the day, or a bracket at the end of the day. But that is supposed to be one. You have to factor out the highest common factor. So you must factor out, or you must factorize the highest common factor, which is the HCF. This is the highest common factor. The highest common factor, which you are going to factor out, which you are going to factor out to factorize that. So I think by the time I'm just talking about the highest common factor, you have something to recall from your grade 8, where you referred the highest common factor concept. So there are two terms, this term and this term. So we are considering the highest common factor, one, in terms of the numbers. If the number is not indicated like that, it means there is a 1. So considering 1 and 2, what is the highest common factor? That will be a 1. So meaning to say, in terms of the numbers, we can decide not to write. Just like here, the 1 was not written, was not indicated, but there is a 1. So even you, if you have to write your answer, if your answer is 1x, it is the same as the is x. 1a is the same that it is a. The 1 can just be left out to be an invisible like that. So that is the idea there. So meaning to say, I'm just going to consider the part of a squared and the part of a. What is the highest common factor? So the highest common factor is going to be a. Okay, so the question is, why am I taking this a, not a squared? Remember, a factor, it is like this. Let us consider numbers. If I'm given 6 and I'm also given 12, if I'm saying the highest common factor, if I divide by that number, I'm not supposed to have a fraction. I'm supposed to obtain exact values. So if I say 6 is the highest common factor, if I divide by 6, if I divide by 6 like this, I'm obtaining a 1. Here, I'm obtaining a 2. That's a highest common factor, is supposed to give us exact values, not to say 12. If you use 12 like this, if we say 12 is the highest common, look what's going to happen. 6 into 6, that's a 1. 6 into 12, that's a 2. That's a fraction. So this is totally impossible. So it is the same thing. If you were to take this a squared and you divide, it is going to be a over a squared. So it was going to give us a fraction. Remember, there are two a's here. Here there is 1. So it's going to cancel. There's 1. Okay, this a into these two a's. Remember, there are two a's, like a times A. So if you cancel, you're going to remain with only a single A. That's A. You're just going to have an A there. And that's a fraction. So A squared cannot be the highest common factor. So at the end, whenever you are having a variable, meaning to say there's a letter, a term A, it can be X, all right? Whenever you're given a variable, given variables. So when given variables, this is what you are going to do. The first thing, the term has to be common. The letter has to be common. All right. The letter must be common. The letter is supposed to be found on these two terms. We must have A and A there. That's the first thing. All right. So this is when given variables. The first thing, the letter must be common. Then you factor out. All right. So, okay, let me just write it this way. So, all right. Sorry for that. So the HCF, because you are considering the HCF now for this part where the letters are. So the HCF is the one with the smallest exponent, with the smallest exponent. That is the smallest index, the smallest power. All right. So remember the exponent, talk of the index, talk of the power. So which one has got the smallest power between these 2 and 1? 1 is the smallest. Okay, comparing these two, 1 is smaller. So meaning to say you are actually factoring a to the exponent of 1. But remember, a to the exponent of 1 is just what? It is just a. So, okay, so this is what exactly you need. But the idea there is that when you factor out your highest common factor, you are going to divide a squared divided to the common factor, which is a. In this case, remember, it's a squared over a. There are two a's that we have here, just like a times a. So meaning to say, if I am to take this into these two a's, I'm going to remain with only single a there, plus we have got 2a, going to divide 2a divided to this part that you factored out, which is a. So the a and the a will cancel. You remain with a 2. So that is what you're going to have at the end. So it must be in a condition that after factoring out, you do not have anything common in this bracket. And also, if you expand this, you must have exactly what you had before. So that is the idea that we are going to use in this whole exercise. All right, let us consider our question. Like I say, we are not going to have all these questions, just 1 or 2 questions so that you see how are you supposed to factorize this. Factorize the following expressions, 3x plus 6. So if you have to check, we do not have x in this part. We just have the numbers 3 and 6, where we can factor out the highest common factor. So the highest common factor between 3 and 6, that is going to be a 3. So if I factor out a 3, it means 3x divided to this 3. I divide to the 3. So this 3 and this 3 is going to cancel. You remain with x. Plus 6 divided by 3, that's 6 divided by 3, that's going to give us a 2. So we've got plus 2 in that case. So that is the whole idea of your factorization. All right, so if you consider number 2 is just a negative that you have there, but that is also one and the same. The highest common factor of 4 and 8. So if you've forgotten these guys, like, or maybe it's difficult for you to figure out that 4 is the highest common factor. Remember how you used to deal with this from your grade 8, where you have to express this 4 as a product of its prime factors. You can even write it this way that you understand. That is 4 divided by 2, which is going to be a 2. Then we divide again by 2. 2 divided by 2, that's a 1. All right. You do the same thing on the 8. You're taking the numbers because you want to figure out what is the highest common factor there. All right. You take also your numbers, which is 8. So you're going to divide by 2. 8 divided by 2, that is a 4. You divide again by 2. 4 divided by 2, that is going to be a 2. All right. You divide again by 2. 2 divided by 2, that's a 1. So this is what you're going to have. So the highest common factor you have to consider, all right, 2 and 2 is common, 2 and 2 is also common. All right, so let me put it this way. So we've got these 2 and these 2. But this 2 is no longer corresponding to anything. So we cannot have this on our answer because the highest common factor is supposed to be common. So there is 2, which is common. So that's 2. There is another 2, which is common, which is a 4. But you're supposed to know this. Like, yes, if you have the challenge, then go back to this idea. It's going to help you a lot to determine the highest common factor between what? Between the numbers by expressing these numbers as product of their prime factors. But if you know this, like by just looking on the numbers, you say, oh, 4 is the highest common factor. Just factor out your 4, straightforward. All right, that's 4x divided by 4, which is going to be x minus 8 divided by 4, which is 2. So minus 8 over 4, that is going to be minus 2. So that is the idea of your factorization. Whenever you are working with your factorization, the steps are clear. This is what you're going to need. All right, so throughout this exercise, that was the situation of the exercise. So I want you to try as many questions as you can. If you consider question number 5, they are giving us 5ab plus 5ac. So if we are to consider 5 is common, so you're going to just factor out 5 in terms of the numbers. Then we've got a and a in this case. So a, the same exponent. Remember I said if the letter is common, you're supposed to factor out the one with the smallest exponent. But they have got same exponent. So we are just going to factor out that a as it is. All right, then we divide 5ab to the 5a. What are we going to have? So 5ab when divided by 5a, you see that these will cancel. You remain with a b. So this is going to be b. All right, plus in this case 5ac and 5a again. If you are to check 5ac divided by 5a, this one, you are going to cancel these 5a and 5a. You remain with a c. So that is the idea that you're going to have. So this is the simplest part that you're going to have at the end. All right, so that was question number 5. I want you to try as many questions as you can. Let us see number 11. On number 11, we are given 15x squared plus 10x squared y. So that's it. Let's check the letters, the numbers. All right, between the numbers, there's 15, there is a 10. So what is the highest common factor between 15 and 10? So like I said, if you've forgotten, do that thing. 15, there's a product of its prime factors. The first prime number that you're going to use, that's a 3. 15 divided by 3, that's a 5. 5, that's a 1. All right, then you've got 10. The smaller number, that is 2. 10 divided by 2, that's a 5. We cannot use 2, you're going to use a 5. So 5 divided by 5, that's a 1. So if you're to check, the only part that is common is this 5. 3 and 2 is not common. So meaning to say the highest common factor between these numbers, 15 and a 10 is what? Is 5. 5, the one that is what? That is common. So if I factor out a 5, all right, sorry, in terms of the letters, there is also x squared. So it is the same there. Y cannot be because it is not common. Remember I said for the variables, for the letters that you be given. All right, it's just that I erased that part, but I think you still remember that I said if you're dealing or if you're working with the letters, which are the variables, X, Y, whatever that you're given, it must be common first. So Y is not common. Okay, so we cannot take this one. So let us factor out this. So if you factor out 5x squared, what does it mean? You're going to divide 15x squared divided to 5x squared. So it means 15x squared over what you have factored out, which is 5x squared. So 15 divided by 5, or 5 into 15, that is 3, right? Then x squared and x squared, these are the same, so they will just cancel. So that's a 3 there. All right, you do the same thing, plus you divide on this part, 10x squared y divided to 5x squared. So this is 10x squared y divided to 5x squared. So this and this will cancel. 10 divided by 5, that's a 2. X squared and x squared cancels. You remain with a y. That's the idea. So this is simply the simplification of your factorization. If you are factorizing, you are expressing your answer in terms of a bracket or in terms of brackets, depending with the type of question that you are given. We are going to see different types of questions in this syllabus of ours. So let us subscribe so that you won't miss any of the classes that we are going to have from Mason African Motives. All right, on number 21, we are given x cubed plus 2x. And again, if there's another question that you see challenging from the question that I skipped, let me know so that we can have it on our next class. So in this on this part, we are given again to factorize. And we can see in terms of the numbers, there is a 1 there. Remember, always the number is not given, it's not indicated. There is a 1 there, which is actually invisible. So if you're to consider on this part, there is x to the exponent of 3, there is also x. So meaning to say we can have the highest common factor. We consider the one with the smallest exponent between 3 and 1. The one with the smallest exponent is x. The one with the smallest power, the one with the smallest index is the one that you factor out. So that is 1x cubed divided by x. So there are 3 of them here. You divide to 1x. So there we are going to remain with 2x's there. All right, plus 2x, when you divide to x, that will be a 2. As you can see, that x and x will cancel out. All right, so what am I trying to say if I say these are 3? Like they are x to the exponent of 3. It simply means x times x times x, remember? So there are 3 x's that we are having there. There are 3 x like this. X multiplied to x like that. So let us just put it this way, times x times x. There are 3 of them over 1x. So it will cancel, you remain with the 2. So if there were 3, they were written as x cubed. What if there are 2? They're going to be written as x squared. So that is the idea. So if you just understand that an exponent means they are these numbers, like the exponent is the number of x's that we have on that question. Just like number 27 here, we are given on number 27, that is 9m to the exponent of 4 minus 9m to the exponent of 3. So if we are to consider 9 is common, that's the highest common factor. There is the same number that we have. So there is nothing for us there to do on 9. Then in terms of m is also common. There is m here, there is m here, but which one has got the smallest exponent? That is a 3. M to the exponent of 3, because this is a 4. So the smaller or the smallest exponent is on m to the exponent of what? Of 3. So this is your highest common factor that you're going to factor out. And when you factor out this, you are expecting something inside of the bracket. And how do you obtain that? You divide back this divided to what you factored out. So it was supposed to be 9m to the exponent of 4 over 9m to the exponent of 3. This and this cancels. So here we are simply saying the m here, how many m's do we have here? There are 4. Here, how many? There are 3. So if we cancel these 3 into these ones, which are 4, how many will remain? There is only 1 m which will remain there. So that is the idea there. So you're supposed to take it like in your mind, take it inside your mind. What is happening there? All right. You don't need like to do this. No, you're supposed to do it in your mind. What is happening here? All right. So that's 9 and 9 cancels. M, there are 4. Here, there are 3. So these ones, 3, if they cancel the 3 that are here, how many will remain? There's only 1 M. So the same thing, the 9 and the 9 cancels, that's a minus. M, there are 3, here there are 3, so they cancel each other. So it's just going to be a 1, because like this, m to the exponent of 3 over m to the x, it's totally cancel. Like, remember, a number, if the term and the term are the same, and you are dividing, that will give us a 1. So meaning to say there, it is going to be m minus 1 at the end, inside of the bracket. So this is the idea of the questions that we have. So I want us to try as many questions as we can. Like I said before, let us just conclude with question number 28. On question number 28, we are given again to factorize 9x to the exponent of 5 minus 32x to the exponent of 2. So if we are to consider this, how are we going to factorize this? So the first thing is considering the numbers 19 and 32. Remember 38, 38 is a product of 2 and 19, 2 times 19. So meaning to say 19 is something that is common between the numbers. So 19 is the highest common factor between 19 and 38, because here it was supposed to be written like 2 times what? 2 times 19. So you see that 19 is the, because there's 19 is a prime number, remember. There are no factors in 19. So that is as it is like that. All right, so you're going to factor out 19. Then in terms of the variable that we have, in terms of the x, it is common, as we can see, x to the exponent of 5, x to the exponent of a 2. So you're going to factor out the one with the smallest exponent, or the smaller exponent, which is x to the exponent of a 2. By factoring out this, you are going to divide again, like I said, but you can do it in your mind. 19 and 19, they cancel each other. X to the exponent of 5 divided to this exponent, x to the exponent of 2. There are 5 here, here there are 2. So these 2, if they cancel these ones, which are 5, we just cancel 2 there. We just remove, because there are 2 here. So these 2, all of them, will remove 2 here. So how many will remain? Only 3 will remain. So it's going to be x to the exponent of 3. Minus 38 divided by 19. Remember, 2 times 19 is 38. So meaning to say 38 divided by 19 is what? It's a 2. Then x squared and x squared will cancel. That will be like this. So that is the whole idea there. You are actually dividing back 19x to the exponent of 5 over 19x squared. This will cancel, but these ones, they are 2. These ones, they are 5. So it's like x times, or you can use the exponents. The bases are the same. I'm dividing, so I'm going to what? Subtract the exponents. That will be x to the exponent of 5 minus a 2, which is what? Which is a 3. Still, you can use that concept as long you understand it. So these are the typical questions that you're going to have on factorization. I want you guys to try as many questions as you can. Where there's a challenge, like I said, let us communicate on the comment section so that we'll be able to revise on that question that you see having a challenge. But for now, that's it till we meet again.